In this part of a tutorial, we will show how to port an arbitrary application to Graphene. Our Graphene repository on GitHub contains not only the source code of Graphene itself, but also a curated set of applications ported to Graphene and known to be working with it. This set includes such applications as Apache and Nginx web servers, Python and its popular components, PyTorch and TensorFlow machine learning frameworks, a Redis in-memory database. But for this tutorial, we will look at the Memcached example. Well, as you can see, there are only 4 files in this Memcached directory. 2 of them are purely informational, gitignore and readme, and not needed for actual porting. The only required file for Graphene porting is a manifest template file. Here we see it, from which we'll create a final Graphene SGX ready manifest file. Also, we see a makefile that automates all the steps required to download the Memcached sources, build them, and prepare a final manifest. But in this tutorial, we will show what happens behind the scenes, and we will run all these steps manually from a bash command line. Now I am in my Linux terminal running on an SGX-enabled machine. I already have the required SGX infrastructure installed on this machine. I also have Graphene cloned and built via make and make SGX'20. Let's look at the Memcached example. What we see here are the same 4 files, and we are currently only interested in the manifest template file. Let's first take a look at it. And we see that the manifest first asks to start the Memcached executable. Then it preloads ellipsisdb shared library. This is the actual Graphene libOS library, which is put inside the SGX enclave. We also see that we can choose to run Graphene with debug logs or without them. For simplicity, our Memcached example propagates command line arguments into the enclave. And next we see several mount points that specify directories with shared libraries and other system-wide files required to launch Memcached. We see that Memcached can be bound to any network interface, but only with port 11.2.11. We also see a couple of SGX-related manifest options. The maximum size of the SGX enclave is 1 GB here, and the maximum number of SGX threads is 16. Next, we see entries for trusted files. These are the files that are integrity protected and thus cannot be tampered with when loaded inside of the SGX enclave. And finally, we see some entries for allowed files. These files are not verified by Graphene, but since they contain some DNS and host information, we do not care much about their contents. And note that this manifest file is only a template. It has a couple of environment variables like Graphene dir and Graphene debug. These variables will be substituted with real values, like the path to Graphene runtime, the debugging option, and the actual path to system libraries. So let's start with our example. First, we need to download Memcached sources. I will use wget for this. Now we need to unzip the archive. Here it is. The sources were put in the Memcached 1521 directory. Well, for simplicity, let's rename this resulting directory to source. I will use the move command for this. Okay, now let's go into this directory and we will build Memcached as usual. We'll start with the configure script and then we will issue make. Perfect. Now we have our Memcached executable. Let's move it up to our Memcached example directory for simplicity, like this. And now we have this Memcached executable here in our root directory. Okay, now we have built Memcached. Let's port it to Graphene. In other words, we need to finalize our manifest template file into a Graphene and SGX ready manifest file. As a first step, we will copy our template file into a new manifest file, like this. As you remember, we saw some stop environment variables instead of actual values, so let's replace them with the values and paths from my particular machine. And for this, I will use the in-place set substitution. Let's say that we don't need any debug logs, so we will specify none in our Memcached manifest. Let's also specify the actual path to the Graphene runtime. In my case, I will replace Graphene dir with my home directory of Graphene. And let's finally specify the actual path to system-wide libraries and files. And since I'm using Ubuntu 18.04, that's the path I have. Perfect. Now, at this point, our new Memcached manifest file is not a stop anymore, but a good and almost complete manifest. The only part that is missing in this manifest are the checksums or SHA-256 hashes of all files that we marked as trusted files. Moreover, we need all the required special SGX files that Intel SGX hardware expects when starting the enclave. To calculate the hashes for all trusted files, as well as create these SGX required files, Graphene has a special utility called pal SGX sign. Here it is. Here is the indication of this utility. So it takes as inputs the Graphene's executable, and in our case we will use the SGX pal executable. It also takes the user key to sign the final SGX enclave. It also takes the our prepared Memcached manifest and the actual executable file, and it generates the final Graphene SGX ready manifest.sgx file. So as you can see, this utility generated the manifest.sgx file, as well as this special memcached.sig signature SGX required file. This file contains such SGX fields as mr enclave and mr signer. Okay, one final step. Now we need to produce an SGX required token file on my machine. So Graphene provides another special utility for this purpose. It's called pal SGX get token. This utility takes the signature .sig file as input and generates a token, so-called einit token SGX required file. Now, after this final step, we have all the required files for Graphene and Intel SGX. So it's time to run our Memcached example. Let's first run the native version of Memcached. We see that the Memcached server started. So let me start a Memcached client, which is a memtier benchmark, in another window to test our server. And you can see that it works nicely. Perfect. Let's start Memcached under Graphene, but without SGX for now. Recall that Graphene can be run with or without SGX. And think of a non-SGX run of Graphene as a simulation of what will happen with an actual SGX enclave and without using the real SGX hardware. So to start Memcached under Graphene, we will use the loader of Graphene. It is called pal loader, and I will remove SGX equals to 1 for the non-SGX version of Graphene. Notice that we add this nobody command line argument to Memcached. This is because Graphene doesn't have a notion of system users. So now we can start the same Memcached server, and we will start the same Memcached client, memtier benchmark, in another window. We see that non-SGX Graphene works. Perfect. Let's stop it. And now the final step. Let's start Memcached under Graphene with SGX. For this, we use the same pal loader, and we prepend it with SGX equals to 1. Now the Graphene loader actually creates the SGX enclave, puts Memcached executable and the manifest into this enclave, and starts the Memcached server. You can see that Graphene warns about a couple security issues, but since this is only a non-production example, we can ignore these warnings. Okay, so now I start the Memcached client again in another window, and you see that SGX Graphene also works. Slightly slower, but works. And that's it. We manually ported Memcached to Graphene by tweaking the final manifest file and generating additional SGX required files using Graphene utilities. Since these steps are pretty boring, we wrote a makefile that performs all these steps automatically when you run make SGX'20. And this concludes this part of the tutorial.